All right, so here is the claim that I would like to show. Constraint equal awards rule satisfies claims monotonicity. All right, so what is the constraint equal awards rule? If you remember, it's basically, well, in short, we denote it as CEAI. So player I's share is going to be the minimum of his claim and some parameter lambda. Lambda is fixed for each player or creditor. However, it has to satisfy the following. So it can't be a random. Each individual's claim, I'm sorry, not the claim, but the share is going to add up to E, no more, no less. Okay, remember this is the individual rationality, the feasibility constraint. So lambda has to be such that whether it is the minimum of these two is CI for some players and lambda, when I add all those shares together, I have to add up to E exactly. Well, what about claims monotonicity? So what does that mean? Well, claims monotonicity intuitively says if any player has a higher claim, well then he should be receiving a higher surplus or a no less surplus. It doesn't have to be strictly higher, either the same or higher surplus, okay? So a bigger claim, always better. So it means claim monotonicity, if CI prime is greater than CI, well then let's call it CEAI, under obviously the claim problem CI prime, C minus I, meaning everybody else's claim stays the same, and then E is the surplus, greater than or equal to CEAI, CI, C minus I, E. Obviously here, one important thing is important. When I add CI prime and everybody else's claim, J not equal to I, this should still be greater than or equal to E, right? Well, it will be because I am not decreasing the claim, I am increasing the claim. So before increasing it, that was true, right? It was the total sum of the claims was exceeding E. And so when I increase it for one individual only, it will still increase it. So therefore, this is still a claims problem. All right, so we don't really need to mention this. All we have to show is that this, if-then statement holds for this rule. So how do we prove this? The easiest way is proof by contradiction. All right? Well, what does that mean? That means the constraint equal awards rule does not satisfy claim monotonicity. All right? CEA doesn't satisfy claims monotonicity. So let me just write it CM. All right? Well, what does that mean? A rule doesn't satisfy a claim monotonicity. Well, that means, therefore, well, first off, there exists some claim problem, right? There exists a claim problem, CE, and individual I, such that what we have is that CI prime is greater than CI, but right? We increase this individual's claim, but his share under this new problem, once we fix everything else, once we take everything else the fix, so everybody's claim is the same, the E is the same, well then this is not going to be the same or higher. In fact, the opposite will hold. That means the agent's a share is going to decline. All right, so that is important. Decline in comparison to what? In comparison to obviously the initial problem where his claim was CI, not CI prime. Okay, so that is what a claim problem, constraint equal awards rule does not satisfy claim monotonicity means. Okay. So this is true. Good. Well, What do I know? From this inequality, let's open things up, okay? As we open them up, probably things are going to be easier to realize for us or see. So what does that mean? Well, by definition, right? By definition, we know that this CEIE is nothing but minimum of CI prime. Don't forget that, okay? So CI prime. So the constraint equal awards of agent I under this new problem where his claim is CI prime is going to be equal to minimum of his new claim, comma, some lambda. But let's denote it by lambda prime. Why is that so? Because be careful, this lambda in the definition will probably change as we change the problem. Meaning as we change the endowment, E, or surplus, or as we change the claims, at least one agent's claim. And this is exactly what we did here. So this is a new problem. One agent has a higher claim. So in that case, the lambda prime which satisfies this will probably be different. Probably, I don't know, we don't know. So therefore, we want to denote it by lambda prime so that we distinguish it with lambda. Okay? So the minimum of this 2 is going to be less than, right, according to this inequality. What? The CEA of agent I, which is minimum of CI lambda. So CI is his original claim and lambda is the lambda which satisfies this in the original problem. Okay, so we do have this. Let's note it as 1, okay? Inequality 1. All right. Well, what else do we know? Try to write everything that you know, all right? Open them up and see how or where they lead you. Well, we also know this, right? Remember, each individual's award, when we add them up, has to add up to the surplus E. So that means the summation I from 1 to n, CEAI, let's call it prime. All right, so the new, instead of writing it CI prime, C minus IE, I'm going to call it CEAI. All right, so under the new problem, each individual's award, not only player individual I, but also all the other players' award may change. All right, so I don't know that, but I want to denote it just to say that it is probably different, CEA prime, okay? So, but by the way, let's call this J because I don't want you to confuse with this I guy and those I's. I mean, this is just an index, all right? This is particular player I, but this is an index. It's not specific to player I. Okay, so, well, this equals to E, but we also know that in the original problem, I mean, when we add J from 1 to n, CEAJ, no prime, is also add up to E. Remember? That's the feasibility constraint. Well, open this up. Well, what does that mean? When I open this up, that basically means the following. The minimum of CI prime lambda prime, right? This is the ith individual's award plus sum of everybody else's award. So I'm going to use a shorthand notation for this. And it's going to be this. J not equal to I, CEA J prime. Okay? And that's equal to E, which is equal to, again, I basically pull individual I's award, which is minimum of CI lambda, plus everybody else, the sum of everybody else's award, which is summation J not equal to I, CEA J. Okay? I don't have any prime here, but I do have a prime here, remember. So this meaning everybody else's claim sum, and this sum may be the same, may be different. I don't know. Why? Well, because remember, in the new problem, I have two problems. In the one problem, I have individual CI, individual I has claim CI. In the second problem, everything else is the same, but player I has a higher claim. Well, this small difference or change may actually change a word of all the individuals, or maybe not. That I don't know. So for that reason, I nevertheless, I can't ignore this prime, because otherwise you're going to say, hey, they're equal, cancel them out. And so this min and this min are the same, but we assumed the opposite, this, and so contradiction. Hell no, this is not a contradiction, okay? You're doing a big mistake, assuming that these two things are the same. Well, you don't know that, maybe they are different. So it is very important to remember that this may be different, and so I cannot cancel them. For that reason, I need a new notation, and so call it prime here. All right? Again, maybe that's obvious to some of you guys, but I just wanted to underline. Well, where am I heading to? Well, as I said, just, write everything you know, and then don't forget them. Go back to them, refresh your mind, and see what I can do about this new equality. Well, this is what I can do. Remember, this term is smaller than this by assumption 1. Okay, but they are equal, so that means this term must be greater than this, right? Because if this is less than this, and this is less than this, well, then that means this guy should be less than E, but it has to be equal to E. So in order this to hold, I have to have that this guy is greater than this. Okay, so this is a deduction, and I'm going to name it 2. So how do I do that? Let's erase this. And let's write it here. Once again, because of 1, and because under both problems, the CEA, the constraint equal awards rule, is feasible, this has to hold. So therefore, I have to have this. This sum is greater than, let me write it here first. This guy, this sum is greater than this sum. J not equal to I, CEA J. By the way, we can't have equality. Why? Well, because this guy will never be equal to this. It is strictly less, so therefore this has to be strictly higher than this. Okay? All right. Well, I am going to open this up and then write it, because, opening everything up is usually more helpful. So what does that mean? That means, by definition, remember, the constraint equal award of each individual J is sum J not equal to I, minimum of Cj and lambda prime, close the parentheses, greater than sum J not equal I, minimum of Cj lambda. So basically, let's ignore all this. Remember, under this 2 problem, or under this 2, on both sides, the Cj are exactly the same. The only thing that differs is lambda prime and lambda, right? What does that tell us? If lambda prime, if this guy is greater than this guy, lambda prime should be greater than lambda, right? This is what this says. Agree? Everything else is the same. So for any player J different than I, Cj here is the same. All right? And so I have to have lambda prime greater than lambda if this is holding. So if this is not clear, well, try to convince yourself. For example, for 2 guys, let's call this 2. Okay? Any question? Well, let's continue. What else do I know? Well, I know this 1 has to hold, right? By 1. I can say the following. Look, I want to now open up this min term, or I want to get rid of this minimum term. So there are 2 potential cases. If Ci is less than lambda, and then if Ci is greater than lambda, or equal to. All right, I'm going to ignore the equal to sign because, well, let's put it here. Doesn't matter really. So again, Ci, either this is true and between Ci and lambda, or this is true. I mean, one of those has to be true. Okay, well, if this is true, Ci is less than lambda. Well, what does inequality 1 tells me? Well, first off, it tells me that minimum of Ci prime lambda prime is less than this guy, which is Ci. Okay. What does this tells me? Well, here, this term cannot be equal to Ci prime. Can you see that? Guys?
Yes.
Well, this term cannot be Ci prime because if it does equal to Ci prime, it basically says Ci prime is less than Ci. But remember, Ci prime is no less than Ci. So therefore, this guy can't be less than, this guy cannot be equal to Ci prime. Well, therefore, it must be equal to lambda prime. What does that mean? The minimum of these two is lambda prime. I mean, lambda prime is less than Ci prime. Okay? Well, what else? And because this guy is equal to lambda, oops, there's no I, sorry. Because this guy is equal to lambda prime is less than Ci. Lambda prime is less than Ci. What else? Well, remember, we already started our if statement. If Ci is less than lambda, and we ended up lambda prime is less than, strictly less than Ci. So therefore, this is less than or equal to lambda. So we conclude that lambda prime is strictly less than lambda. Contradicting with 2. Is that clear? Any question, guys? Because this step is very important, because exactly the same reasoning is going to be playing in the second case. What if Ci is greater than lambda? So it is very important that you understand this entire logical deduction. Any question? So let's continue with the second case. What was the second case? Let me give some space between these two. What if Ci is greater than lambda? Well, remember, this entire logic will hold even if Ci is equal to lambda, because this lambda prime strictly less than lambda is coming from this, which comes from this, which comes from this. I mean by 1. So therefore, whether they are equal or less doesn't matter. The entire logic will follow. So because I already covered less than or equal to here, now I'm going to look at what if Ci is greater than lambda. Remember, these are real numbers. So one has to be greater than or equal to the other. So either this is true or this. Well, when this is true, what do I get? Well, first of all, I'm sorry. Let's apply everything here. This is the minimum. Ci prime lambda prime is going to be less than this term. So the minimum of these two is, according to this, is lambda. Okay, well, what else? Well, here, I don't know what this min is. But, I mean, whether this is the min or this is the min. So, I don't know. So, if, for example, the min here is lambda prime, all right? So, I mean, if this is lambda prime, I already showed that lambda prime is less than lambda, which contradicts with 2 again, okay? So therefore, let's suppose this guy is Ci prime, okay? So this is less than lambda prime. All right. I mean, do you see that I need to analyze all potential cases and reach a contradiction? All right, so maybe I should just write it, because, you know, sometimes when I skip it, you may think that I am actually skipping part of the proof. I am not. I'm just saving some time and space. But let me write it. So here I have, under this case, 2 sub-cases. If Ci prime is greater than lambda prime, well then, because of this inequality, lambda prime is less than lambda, contradicting with the second fact or assumption. It's not an assumption, it's a fact which is derived from the first assumption fact, which is derived from this assumption, right? Because here there's only one assumption we made, which is the fact, which is that the one that there exists a claim problem where this holds and this holds. So that's the only assumption. Everything else is a fact, follows from this this assumption. So, well, then the second case, if Ci prime is less than sigma prime, well, in this case, what do I have? Well, I have the following. This term is going to be Ci prime because it's less than lambda prime, which is less than lambda, okay. But what do I know? I know that lambda is less than Ci. Well, what do I contradict with? Well, this one. Remember, I did not number this. Maybe I should have. So this is a contradiction because I know Ci prime is actually greater than Ci. So that's also a contradiction. Is there any other way or case that I haven't analyzed? No. Once again, this guy is either, I mean, Ci is less than or equal to lambda, or this is greater than or equal, greater than lambda. And either case is going to lead to a contradiction. So that means there is something wrong with my assumption. Remember, everything else is not an assumption. They're just facts we deduce from this assumption. So because I'm reaching a contradiction, regardless of the cases I look at, well, this assumption is wrong. So therefore, I should just write it somewhere, maybe here. Thus, my rule CEA satisfies claims monotonicity. That's it. Okay? Any questions?